side of that is Microsoft Office. In Microsoft Office, they're not willing to get rid of any UI because someone knows where it is. So
Yes.
every time they try to clean up their user experience, you end up with a seventh place where you can make that change.
So welcome to Coffee Compiler Club, where we're bitching and moaning about bad UIs. And maybe compilers too. But I will say that it appears that the Zoom UI changes on a daily basis, and I can't find from week to week where the buttons went to. Sad, sad, sad state of affairs. I have one new person. Yorin, you want to give yourself the 10-second? Who am I? Why am I here?
My name is Yoran. I'm interested in compilers, so that's why I'm here to learn.
Sounds great. Thanks. And I have a minor agenda to show. I put together a tiniest REPL for simple and promptly found bugs with it. And I know Yorick was thinking he wanted to share something about Inko. So you want to do something, Yorick?
Uh, I mean, I think your demo's probably shorter because I'll probably sort of kick off a whole
Oh, I see.
rant debate.
You'll ramble on and on
No,
about
I
something.
don't think I will ramble. I think other people will jump in. That's more it.
Oh, okay. Those are the best kind of demos, though. Um, yeah, I just threw it together so I didn't get a chance to do any polishing on the thing. So let me, let's go to like this font big enough.
Yep.
Yep, something.
Yep.
We can do this. Is it enough yet on my screen? I'm trying to shrink the right edge, which went far off because Emacs never got clued into other people's UIs.
Yeah, I think that's big enough for Zoom. I don't know about YouTube.
Um, oh, I have no idea. I'm assuming it is, but I could be wrong. So somewhere in life,
I've
I'm sure
definitely known
you,
streamers who set their entire screen to 1080p so that it's the same as the high def
when
YouTube.
when I streamed, I did it, but I grabbed the streaming tool OBS or whatever, and it had a mode, and I chose it, and fine. I had the giant font, and it worked, and it's visible on YouTube. But there were only a handful of people who watch me code stream. They were like passionate. I want to watch, but then on the Chaos Monkey, whatever the query, the poll, a bunch of people said, "Well, watch," and in real life, no, I didn't watch, and it was like a bitch to set up and program with the tiny screen, giant font. What was I doing here? Oh, I had all kinds of things going on. I'm going to unwind some of my bug fixes. So what a REPL means is that it's actually just a command line driver for simple done in Emacs. So command line driver says Java, and after a while, after the giant class path, it says call main, which main just says read a file, throw it into the parser. Here's your one argument value. That's it. And then, whatever happens. And then the bug reporting is still, not the best. If someone wanted to jump in on, putting proper bugs out, that'd be nice. But it does mean I can hit the button and just get the screen parsed. And this one was arrays of reference types must always be nullable. And this is me, trying to figure out what it means and sort out the bug message. And the bug message is really, I declared PS be an array of persons, but it's not person or null. And that means I can't make one and have it be full of nulls because it's not allowed to have a null. So where's an argument about the default that should be on arrays, or you could argue that I want to have a constructor that will build me an array of all not null things. And it's still blowing up. And if I went to the error location, I think I find eventually it's like this one over here. It's also got the same problem. And then it's accessing unknown field age from Persian. That was a typo on my part. My fingers just went too fast. Oh, it's not R, it's H. And if I run again, I get, oh my God, what is this horrible thing? Well, it's a bad message, that's for sure. Argument 0 is a pointer to an array of pointers to person question marks but must be what? And then this is the dump of the internal array structure stuff, including the array elements internal type, but must be a pointer to a person, question mark, same, of the internal type, same of, and then tiny here is the bang. Okay, the bang says it's got to be mutable. I can't mutate elements I pull out of the array because it's deep immutability. So this is a deeply immutable array of persons. I'm allowed to read it only, but I'm doing a plus plus on something I got through the person pointer. That's not allowed. So I claim bad error message. I don't know if it's a bad language style as well. There I can mutate. Expect an identifier found. No, I don't know where this one came from. I thought I had this fixed here. Let me go see if this was part of it. Nope. Okay, so now I don't know what the error is. Why would you? Oh, you can't have it there. It has to be here because I'm passing you an immutable array and he's mutating it. And there he goes. Yes. Okay. So arguments to functions aren't like declarations. So it's not a mutable or not mutable thing. But I can't pass an immutable PS array to a function which mutates it. So I have to declare the array is mutable persons. So the persons I make that go in, they can be mutated by somebody who pulls out of the array. So that's as far as I got this morning after I sorted out why all the things and the error messages that were bad. And there are other issues I sorted through, and I was like, this is kind of cool, but you can type and hit bang and type and hit bang and, and get an error. And then, what did I type wrong? Where the error message needs to be better. Sure. But kind of sort of makes sense. Here's sieve of eratosthenes in a file. And try again here because Emacs and this, there you go. So there's the first 100 primes here because we're glutton for punishment. Oh, I blew up because I didn't say, why did that blow up? Well, now we don't know why. I don't have any size limits in here that I know of. Unless there's something, look at this, there's 250, there's 200. 500 blows up.
If you don't pass in a file, does it just take it from standard in?
No, because I grabbed the string and then just open a file. But I could put a dash there and teach that one. I probably have to teach that one. Where does he blow up? Okay.
Because the fun of a
I'm
REPL is always when it's
confused.
taking it from standard in and giving it to standard out.
I mean, I could totally make a pipe out of it. Yeah. Then it becomes, an awk thing. I could also take it off the command line. Like this is all done in all done in 30 seconds or less or something. Let me throw Yasser in. I mean, I'm trying to binary search my way to why 400 blows up. And that's almost surely something stupid happened in the evaluator that should have exploded on me. Well, there you go. Oh, that makes no sense at all. I have no idea. Okay, now I'm terribly curious, but it's just very boring to debug this live. I'd have to pull it up. What the hell? Who cares about 375?
Do you have a max stack depth in there somewhere
Yeah,
that
right.
you're doing
Yeah. There's some
recursion
sort of
rather than
limit that's arbitrary somewhere.
tail call elimination?
Oh, you know what? The evaluator has a hard cutoff that takes a default length. He runs so many steps and he stops. Because I routinely write junky broken codes out of the fuzzer that run forever, infinite. So the evaluator by default, I didn't change the default. So the evaluator, the evaluator said you hit 10,000 iterations, you're dead. That's what that was.
Right, but that should return a class that is the 10,000 iterations killed throw or whatever.
There's
It shouldn't return null because it timed out. It should return timeout.
yes, the null is the timeout. It never returns a null unless it's a timeout. And so that my error handling on the flip side is not there. So the actual timeout is actually 1,000. So So that was pretty quick then. Let me believe I got the right thing here. Oh, I reset my tags. Oh man. It is. That's the correct one. Okay.
We did talk about that years ago about having an evaluator where every function has a budget and every function it calls, it must pass some of its budget down into.
Yeah, okay. So can't hit there, but let's go 500 now. Oh, yeah, this thing's probably n squared. No, did I not get it right? Did I not build? I'm not running the build step because I'm running the damn thing. Where's my build step? Oh, there you go. Painful. Wrong way to go build. So there's the build. Now I've changed things. And there's 400. And there's 10,000. So the evaluator, despite being completely an interpreter, is, you know, fast enough to do something. Steve, nope. Steve, yes. So there it is. There's sieve eratosthenes in simple running reasonably fast. And that's my demo. I threw that together this morning in 30 minutes or less. The other part of the demo was just say, I have functions in simple and they actually do something useful. You know, it does a reasonable thing. And now I have other function demos I could go after. Sure, function 2.simple. What do we got here? Val function is equal to r question mark int x or x times x colon x arrow x plus x. And then let me actually say this. If r and 1 equals 0, which would just be this, and then function of arg, maybe I can color mode you a little bit. And then we'll do function 2, simple of 0. And he expects a semicolon somewhere. What's this blow up? No, where am I missing a semicolon? Oh. Expected an arrow. Yes. Bad type. Boom. Okay. And change this to a 1. 1, change it to a 2. That's not very definitive. So 3 is odd, so he squares, and 4 is even, so he adds, and 5 is odd, so he squares, and 6 is even, so he adds. So basically, I've made 2 anonymous functions, and I can pick between them. This is bad coding style here. I don't know. The better. That might look a little nicer. So functions are anonymous. They can be used in expressions arbitrarily. Oh, here's Arthur waiting. I'm not paying attention. I lost Arthur. I should get him in a minute then. There. Yeah. Function declarations, anonymous functions. There is a plan to turn them into methods. Like I'm a short syntax hack away from making methods out of them.
How did arg show up as a number? Shouldn't the input have been a string?
I don't have any strings.
Ah,
So,
okay.
so replace arg with arg pound, and it's the length of the count of arguments. But I have no strings yet. And in my head, strings are waiting on a couple of pieces of syntax sugar, and then I'll have strings. One of them is methods. One of them is fusing arrays and structs, because I can do that. And it's pretty straightforward. And then I'll have methods on arrays. So I can say array.map or array.mapreduce or array.find of an element, stuff like that. But then a string would just be extra methods on an array of cars. And then
When you're simple syntax, how do you indicate an array or a multi-count field in a struct?
well, an array, so I don't have fused structs and arrays. So I'll show you an array and a struct. It's just exactly how you think it is. There's an array of cars in my struct. Let's call this a string. There's an array of cars in there, right? It comes with its own built-in length. So maybe I want a hash function, and I say the hash function takes, and here's, I don't have a method syntax, but it would say like a dot, and then I'd have access to self. And then I would say for int I equals 0. We can actually do this far. I don't have that syntax in either. I'll just do the part like I less than length. So if this was a fused syntax, I would say CS, I could just say length. If it's not, I could say CS length. This is being a method oop where I'm saying it's like self.cs. But the self is implicit, just like a C++ normal virtual method. So it's CS pound. And if I fuse things, structs, then this CS would be fused as part of the struct. And so that could be done that way. But I'll leave it this way for the moment. So that's the length, I++. And, hash equals whatever, hash times 31 plus CS of I. And I better put a hash up here. And there's my hash, but I have to return it. And maybe I actually want this to be private, and I have some syntax trigger not involved where I say underbar means you're private, and I have a underbar hash code, which is also private, and then I have an exposed guy, which gives me the hash code, which says, if hash code's been computed, if it hasn't been, then I'm going to say hash code is equal to hash, go compute you, and otherwise I want the cache. So lazily compute the hash code, in theory. With Java mode.
Does seem a little cleaner to have a hidden field than to self-mutate and just change what is at that field to a constant.
Oh yeah. And then somewhere in here I probably have to have like if not hash, then get a default hash if you're 0. I don't have dead beef, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, fine. So, here's a little things for hash. Maybe I also want, oh, let's see, I'm declared myself Java, so I get more indenting now. All right, you're confused. Yeah, okay. And then I would say equals, right? Whoops, equals is takes a string, s, arrow, and then I need another one of these for loops. All right, I'll start with some easy cutouts here, right? If self equals s, you come true. If now in the land of I have direct access to the array, I can just say the array length is equal to s of length. That's the length of string s versus my length. But I don't, so I have to say cs, s.cs. And if the lengths are different, I'm just going to return false. And then otherwise, I'm going to start this hack, which just says, cs of I is unequal to s.cs of I false. And then maybe become true. I don't know if I missed some hack there. Something like that. So these things all beg for being methods. They're not. So this syntax is not correct. I don't have a self pointer. To make it valid today, I would have to say something like self, but this is like Python objects. There is no actual method call. You just pass a self pointer in. But I have to get the equals from some prior string, which is kind of silly. This equals method takes no interesting arguments, takes no this pointer. It could be stored outside. It would be perfectly valid to be out here. But it could be in here, and then if I pass a self pointer hidden, I could get rid of passing it explicitly. And because, do it the correct way internally, it's got to be self dot, self dot, self dot, self dot, blah, 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 blah. And if I go try to compile this, run it, I'm sure he'll tell me, I'll all kind of syntax errors. I'm not paying attention. This dot fields might be null. Can't read or write length. Oh, I didn't do null check on any of these things. This field, why would you be null? Or did I catch the wrong one?
I mean, if you didn't initialize it.
Yeah.
Okay, cannot read or write length. No, this is a struct, which means if I were to make a new string, oops, yeah, I have no, the initializer syntax is you can fill things in here, right?
Right, but don't you need a function named string inside of string in order to do that?
I'm sorry?
Where do those initializer parameters go? You don't have a function named string inside of string.
Okay, this is a struct. So I just say
Oh,
new
those
struct.
are braces, not
These are
parentheses.
braces. Inside the body of the brace, I can run anything I want, and it gets to see the fields that are present in the struct and assign them. And if I fail to assign fields that must be assigned, I'll get an error at compile time saying, hey, you failed to assign CS or whatever. But this test is saying I believe something is null and I didn't test for null. And almost sure that I can start here. I don't know where it is because my error, I have to bring it up in the debugger and look at where the error message hits because the exception throw is not giving me the line number that I fail on. I have actually tracked the line numbers. I just not put them in the exception when I blow up. So this could be a thing like, pass the null in. I don't know which one of these is blowing up on me. That's unfortunate. As far as I know, I didn't say this guy is nullable. He's not initialized, so he should be required to be initialized, which means the code above should say it'll always be not the null. I don't have to test for null on CS. So this looks
And we
like
know that that array is not nullable because of the absence of a question mark?
yeah. If I had a question mark here, I believe, so here, it would say I could have a null character array. And if I don't, then you can't have a null character array. Now, I could be wrong because, I've just thrown this thing together. We have a handful, well, we have a couple hundred test cases, but I haven't coded in anger. With the REPL, I can code in anger. But first thing comes up is, I need fucking better error messages to code in anger. And now the question is, bring it up in the debugger, which I can totally do. And this demo gets longer and longer. Or I can start playing guess and set, guess and test. Hey, maybe it's because I didn't test self.cs is null, right? If that is not null, that's null, then what the hell am I going to do here? I want to say, I'm going to return your true or false according to x.cs is null. So if self is not, and the other guy has a string, then I'll say not equal. So I get this backwards, true. And if self is null and you're null, then it's true. Yeah. So there's that. But then if s.cs is null, turn false. This is all me trying to say, this happened first. I'm trying to throw in which null check I'm failing on, and I haven't figured out which null check I'm failing on yet. And it could be in the hash code.
And all those fields get hoisted to the type because they're immutable. So the only thing that actually shows up in memory when you knew a string is the array?
The immutable fields should get hoisted, yes. No, the var hash code will stick around too. But the immutable field, so the val equals yada yada. Oh well, here. Okay, array of reference types will always be nullable. And where do I have an array of reference types? Car is not an array of reference types. All right, so I need better error messages. It's pretty obvious. And I'm kind of, I thought, no, maybe I did. expected an arrow, didn't like a dot, because I don't have a thing. So this is all self dot. And I have to check for null again. Okay, so right. So there's something's missing with the declaration of CS that I haven't figured out that says it shouldn't be nullable. And he's demanding I check for null. Right, actually, we'll do this. And he still thinks there's a null check I am missing. So now I don't know what it is. Let me go over here and take this guy out and make sure I'm not getting confused here. Yeah, something happened in here where he oh wow. Well, now are you declaring null? Oh, I'm missing something more basic. Oh. I don't have the right. Oops. How about now? Wow, I claim no check in here. Why are you blowing up on me? That is interesting. Okay, so where do people want to go from here? I can go pull up the debugger and sort out where this is coming from. I'm missing something basic. And then, presumably flows together. Or we could be done and claim, hey, there's a quick turnaround. I can go edit and hack, and something happens. And the error messages are there buried in the debugger, or the error, the line numbers and stuff are there buried in the debugger, and I have to pull up the debugger. Or we can switch and go do something else. No one has
Let's
any
hear
opinion.
Yorick's thing.
I'm sorry? Someone started to say something and stopped.
I said, let's hear Yorick's thing.
Let's hear York's thing. I got a vote for York. That sounds good.
Sure.
Yeah.
Let's see. It's been a while, I think, so I don't know where I last left off, but basically what I've been working on the past couple of weeks is adding support for stack allocating types. So in Inko, types default to the heap, and this is a sort of core part, like it's deliberate. Basically, the idea is that I wanted it to be possible to still move data around when borrows to it exist. So for example, in Rust, that's not allowed. That's what the borrow checker does. It brings in many benefits, but it can also make working with Rust really difficult at times. Self-referential types is
Are you
usually
lifetime checking at
no.
compile?
So that's saying Inko doesn't do that. There's no lifetime checking, borrow checker, whatever you call it. In part because I think for like a low-level language like Rust, that makes sense. So if you have something you want to run on like an ESP32 or
So
critical
I was under
stuff.
the impression you didn't have a garbage collector either. If you're not tracking
Correct.
lifetimes or collecting garbage, who's freeing memory?
So it does have single ownership. In that sense, it's similar to Rust. It doesn't do compiled on board checking. At the sort of basic level, the way it works is types default on the heap, and they have an object header which contains a reference count. And if you have a owned reference and you move that around, nothing happens to that reference count. Like you just transfer ownership. And you can't use the old reference. If I borrow it, what it does, it will increment that count. And then when you're done with the borrow, it will decrement it. And then to ensure correctness, when you drop or deallocate a owned value, it will check that reference count at runtime and say, hey, if that is above zero, produce an error, terminate the program. And that area will print the stack trace, etc. So it is essentially
So if a
a
lent thing goes out of scope, I get a runtime explosion that says, hey, a lent
yes,
thing just went out of scope.
yes,
You
basically.
fix it, programmer.
Essentially the closest equivalent is standard reference counting, but instead of some reference sticking around because the count is still one, it will say error, fix your code. This idea itself is not new. It's from a paper originally published in 2007, I think. where the author applied this to essentially a subset of C sharp, I believe.
I mean, I like that a lot better than use after free bug.
Yeah, so I mean, so it is, technically it's sound. Like you can't have use after free bugs. And because data defaults on the heap, you can safely move it while borrowing, because all those borrows, they're just pointers to that heap data, so they remain valid. But obviously, at the basic level, it's not the most efficient approach. So for the counting, you can do the standard reference counting optimizations. I don't do any of them right now.
You say move it around. I mean, do you do cross-thread things with it?
We'll get there. So that's sort of the foundational level, right? But then you have threads. They uh, they pose a challenge in that, if I move data from thread A to B, how do I guarantee that A does not retain references to that data, for example, or that the data contains references to something that A still has? For that, I took this idea from a language called Pony. Well,
Yeah.
technically, I took it from the paper that Pony based it on, but potato, potato. But the idea there is basically you have this construct known as recovery, and essentially what you do is in the code, you start a block, and within that block, your access to data outside of it is severely restricted. So you do have access to types that you can trivially copy, like int, float, boolean, that sort of thing. Everything else is exposed as a very restrictive borrow, which essentially means you can use it to some degree, but the compiler basically guarantees that you cannot, for example, mutate it such that the data inside this recovery block will point to data outside of it or the other way around. So essentially, it's this sort of, in the original paper, they call it isolated or isolation, like it's this isolated chunk of code where you have restricted access to the outside world. And then the interesting of it is that whatever you return from that block is guaranteed to, at that point, not have any references pointing into it from the outside. So to visualize that, you start recovery, let's say you create a user in that block, and then you return that, right? When you return that value, any sort of unused values, borrows, whatever, they are cleaned up first. Because the way move semantics and such is implemented, at the end of a scope, it will drop whatever you're not returning, basically. So at the end of that recover block, you have your user. And because references and such cannot escape from that block, nor can they sort of point into it from the outside, you have this guarantee that at that point, there's no references pointing towards that user value. It is valid for that user to contain references to itself. But the end idea is essentially what you do is you take a cardboard box, you put stuff in it, you tape it up, and then you're like, here's the box. Stuff inside the box may refer to the box or other things inside the box, but you cannot refer to things inside the box from the outside or the other way around because the box is closed, basically. And that means that at that point, you can safely move it to other threads because all the data is fully self-contained.
Contained, yeah.
And then what I've been working on the last couple of weeks is to basically solve this issue of, okay, everything going on the heap by default is fairly expensive, especially for very small, very short-lived values like optional types, your typical result types. Anything that basically lives for like less than, let's say, one call frame, it's kind of a waste. And so I've been working on adding support for stack allocating types, but retaining the safety and such, which without borrow checking is quite tricky because you can't just return stack allocated data because borrows might still exist, but they are at that point invalid. The technique I ended up using there is he had borrowed from Swift, where in Swift you can define classes and structs. classes go on the heap, they use reference counting, and then structs go on the stack, and they use copying. But then Swift has this interesting idea, which what I copied, is that if you have a struct containing heap data, so class values, copying the struct will also increment the reference count of those heap values. And then when you drop the struct, it will decrement them. And so Inko now does something similar, which means that if I borrow a stack allocated type, it will copy the data that exists on the stack. And if that contains any heap allocated types, it will then increment their counts. So the benefit here is that the sort of unstable portion of the type that exists on the stack can never be invalidated while you still borrow it. Because you don't really borrow, you copy it. The downside is that if you have a stack allocated type that contains, let's say, 10 fields, each containing a heap type, then borrowing that stack type requires 10 independent increments. And so the sort of recommendation there is basically you want to do this if it's like a fairly small type or you're not borrowing it much. And that in itself was a bit of a challenge to figure out, how do you make this work? How do you make it safe? Required fairly extensive changes in my compiler. For example, type specialization was built under the assumption that everything was basically heap allocated, apart from like int float and a few others. So that had to be extended to now support arbitrary defined stack allocated types. Other challenge that I spent way too much time on is dealing with ABIs, specifically the ABIs when you start passing structures around as arguments or return values. And specifically the fact that llvm basically lies as far as its support for the C calling convention goes. Essentially, in the document, it's like, hey, we have support for the C calling convention, but it's actually like sort of like as long as you don't use structures, it matches. Essentially, the problem there is in llvm, in the IR, you can define a function that say takes a structure of, let's say 3 64-bits integers. And in the IR, you can type such an argument as just a structure. That's it. The problem is that when you compile that, it will not necessarily compile it to the code that is needed for your target's ABI. And so, for example, on both AMD 64 and ARM 64, a structure larger than 16 bytes should be passed as a pointer. And so if I have 3 64-bits integers, that should go as a pointer. But if I declare it as just a struct in LVM, I think in AMD 64, it will try to like split it into separate arguments. I don't remember exactly. I don't fully remember what it does on ARM, but basically it's not correct. Like you run the program, it explodes. And the worst thing is it will explode in very vague ways. Like if that's the only function you call, it will work. And then you call a bunch of others, it will still work. And then at some point, because of how it decides to allocate registers or whatever, it will break somewhere deep down with some completely unrelated symptom. Like it will break in some unrelated thing and you have no clue why. So I think I had to solve that in several instances where I thought like, okay, this time I fix it. Oh no, wait, shit. If I now use it in this way on Mac on ARM 64, then it will fail. So that was, I'm pretty sure I got a couple of new gray hairs in response.
So when you say you fix it, do you fix it in LLVM or you just work around it?
So part of this was I wanted to figure out, okay, am I just doing something wrong? Is there perhaps, a solution in LLVM that I'm overlooking? The conclusion there was basically, no, this is by design. This has been this way since at least 2007. Where on the mailing list, basically you go back in time, you find way back in 2007, Chris Lattner saying like, oh no, this is basically by design. And from what I understand, it's because hypothetically certain optimization passes might be able to benefit from this. And the other argument is like, oh, we do it in Clang, so we don't do it in LVM. So the usual recommendation is like, oh, just look at this giant file in Clang and just copy it.
Yeah, I've seen so if you look into the code for Zig or an Odin, they have this gigantic like 2000 line thing that just deals with like how do you destructure a struct for system V, how do you do it for Win30 or Win64, and every single variation of that because they're all going to have like their own wacky stuff.
Yep. So
Yeah,
I
if
currently
LLVM
have
is doing internal like linking of like two functions, it can get away with like a BS that doesn't have to match the ABI. But if it's like linking against like external stuff that needs to actually abide by the ABI, they're like only half helping you. Like they'll deal with basically the piece that says which registers go in which places, and then like the rest is all up to you. Do you want like this thing like, oh, does this thing fit into 64 bits? Well, you have to put it a 64-bit integer, even if it was a struct and it was like made up of multiple fields.
yeah. So the
Right, but if you
interesting
can
case, what
pass your
I
struct in registers, that's a huge performance win compared to writing it out to memory and then reading it back. Like
Oh no, I don't I don't
that effort's
disagree, but
worth
like
it.
you have to do that manually if you want to get that to happen.
right. So
Yeah,
the weird
and
thing
System
there
V does
is
expect you to do that in certain places.
the weird thing here is like people have written that like, oh, it's fine if you use your own ABI. Like I'm basically using my own OBI, it still crashes. Like I wasn't like passing structures to C functions. I'm pretty sure I ran into a case where I had a uh oh my mic. Where I just called my own function with a structure or returned it. No external C functions involved, and it still blew up. And I one thing that isn't quite clear to me, for example, if you look at the Clang IR, when you return structures, it does some little fiddling with mem CPI instead of sort of loads and stores with the appropriate types. It seems that when you do not do that, LVM just straight up generates bullshit code. So you basically have to generate the same IR that Clang does, but I'm not convinced that it's needed because that's sort of designed that way. It seems it's more like that's what Clang did, and the optimization passes are written with that in mind. And so if you don't do that, you get bullshit. Because I've had
Yeah,
cases
there's
where
definitely
no
like a
optimization
clang.
it will work
There's
fine.
definitely a clang bias in LLVM,
Yeah,
which
like
to be fair makes sense. Like it is probably their biggest, if not the biggest by far, like actual user of LLVM. So like if you want optimizations, you're gonna want to like make things look like C or C++.
right. No, it's
Well, there
hold on, let
is a
me.
document, like something like advice for front-end developers, which documents some of the assumptions of the optimizations. I personally didn't look much into what Clang generates, but we don't do anything around like passing structs, so we just never touch that part. And yeah, over time, we in part documented some of the things that optimizer expects. But I don't view this as a Clang bias, but it just yeah, there are some patterns that are more, I don't know, canonical for LLVM that it expects or deals with better.
Right. So there was a case where to highlight the mem CPI stuff, like on AMD 64, if you return a structure that is less than 8 bytes, it should be returned as an integer with a size equal to it in bits. So in other words, if I have a structure that contains a 32 bits integer, at least what Clang produces or what seems to be expected is that the return type is specified as a 32 bits integer. Similarly, if it were 50 bits, you'd say, oh, this is a 50 bits integer, and then it gets rounded up. Now, I couldn't figure out why you can't just always round it up to one word, but this is what Clang does. The thing is there, if you, this case where you call such a function, normally if you want to sort of like cast it to your desired actual type, you do that with loads and stores where it has the appropriate source and target types. And assuming the memory layout is the same, that should work just fine, right? Like if I have a 32 bits integer or a structure that contains a 32 bits integer, that will pretty much always be the same memory layout. Like technically it can differ, but in practice it's always the same. If you do it that way, it will not work. Like you have to use mem CPI. I couldn't figure out why. I spent a couple days on that. But that's what I mean with the clang bias. I suspect it's that the way these code generator passes and optimization passes are written is they assume this pattern of, oh, we do a call, then we do a load, a store, and then a mem CPI and blah, blah, blah. And if you don't do that, it's like, we give up. And so it's basically, I linked this article on the doc, but my takeaway there is that basically llvm lies about, or at least not clearly states how it handles the not even the C calling convention, but the system ABI. It just happens to be that the two are usually the same. In that it will say like, oh, you can use structures, but it's basically with an asterisk that says, yes, you can use structures, but be prepared to tear your hairs out. But I got it working for AMD 64 and ARM 64, which is the only two targets I currently support. No idea how this is going to work in the future if I ever add support for, say, RISC-V or RISC-V or something else. And I wouldn't be surprised if there's some weird corner cases where it doesn't handle it correctly. One thing I haven't looked at is dealing with SIMD, because on ARM 64, they have this notion of, I don't know if it's homogeneous or heterogeneous, floating point aggregates, like HFAs. But basically, ARM has this rule where if your struct is 16 bytes or larger, pass it as a pointer. However, if it contains up to 4 either 32-bit or 64-bit floats, in case of the 64 bits, it's going to be 32 bytes, you can still pass it as is. However, if you have, say, a structure that is 2 32-bit floats and 2 64-bit floats, pass it as a pointer. So it has to be the same types of flows up to 4 values. There's a similar rule for like what they call like vectors related to SIMD. I didn't bother with that because I don't support SIMD yet. But I suspect that's going to be a bit of a challenge as well. But yeah, this is, I think my conclusion in the end is like, for anybody writing a new sort of compiler backend, dear God, please implement this in the backend so that not everybody has to re-implement the same logic. Because I looked at a couple of big projects that all ran into the exact same issues. Like basically C#, some Smalltalk implementation, Zig, Odin, bunch of others. Essentially, the moment they add support for passing structures around by value, the bug reports start coming in because they have to implement all this complicated logic. So yeah, that was the last couple of weeks. And then the sort of tail end of that is that currently closures are still heap allocated, which is something I want to get rid of. I want them to be stack allocated. The challenge there is that if you define a function as taking a closure as an argument, the size of that closure can vary based on how many variables it captures. So you'd essentially have to specialize over closures similar to generic types. But then pose this interesting question, like if I take a argument typed as a closure, if I define a closure in my function and I assign that to variable A, and I capture a bunch of variables, and I assign variable A to B, you have to make sure that within the type system, it sort of carries on that capture information so that it knows, so if as this closure is passed around, we know exactly its size at all times. That's, based on what I've seen so far, it's going to be quite tricky, so that I have postponed. And then the final thing I'm working on is that the one of the caveats of my stack allocated types is that because they are copied, you cannot assign fields new values because you would be assigning on a copy, not the original. So you can end up with this pattern where you think you're modifying a field, a type by assigning a field a new value, but you're actually modifying a copy. And this is something surprisingly Swift allows you to do that. And unsurprisingly, Stack Overflow is full of questions. People saying like, hey, I assigned a field a new value. Why do I not observe it? People are like, oh, that's because it's a copy. So my compiler says, no, you just can't do that. Because I would rather have it tell me you cannot do this than find out the hard way I did it wrong. But that limits it in terms of what you can use it for. So one case is iterators typically are like stateful iterators. They rely on being able to assign fields new values. So if you have an iterator over an array, that will contain some sort of reference to the array and an index. And so to advance it has to store the next index back into that iterator structure. For that, I'm basically working on at least investigating if it's going to work into uniqueness typing. The idea being that Inko already has uniqueness types in the sense that this recovery mechanism I mentioned, it essentially creates a unique, not a unique type, but a unique value. The idea is that the idea I have is if you extend that to the type definition, as in you say, here's a type that is from the very beginning unique. That means that when you construct it, there can be no borrows of that type. And so it is safe to put it on the stack because as you move it around, you cannot invalidate any borrows because they cannot exist. And that also means it's safe to assign fields new values because it always goes through the same reference to that thing. Now I say you can't borrow it. My compiler does let you do that in restricted forms. But that's what I'm currently implementing to see, okay, is that actually practical for things like iterators, potentially others? But yeah, that's basically a stack, allocating types and ABIs, and wishing there was something other than llvm that was sort of equally mature.
Yeah, I ran into the ABI thing, and my basic solution was my backend doesn't have structs as like a type in the backend properly, but the way that I do it is that I have debug info, so I can use the debug info to describe C structures because that's basically all it does, and then I can tell the user, hey, if you pass me the debug info that describes like C structures, like oh these integers and these things, I'll destructure it into like the correct thing for the ABI. And then I'll pass you back pointers that like logically hold the structure. So for instance, if I pack something, so system view might say like if I take 8-bit like if I take 8-bit like parameters as a value, like if those were in a struct, those could actually get packed in a 164-bit value. I would basically deal with the job of basically packing those into the packing those back into the C-like structure of it. So from your perspective, you get back this pointer that looks like a C struct, but it was composed of a bunch of weird crap. And then my optimizer can unravel that because it's mostly just like a bunch of like boring stack slot moving.
So in that case, in the IR, see if I understand it correctly. Like let's say you want to define a function that returns a structure, say 264 bits integers.
Mm-hmm.
How is that return type expressed then in the IR?
The return type. Well, so in the IR, I could just return you can return multiple scalars.
Right.
Yeah, and that's
And
just like API based. So like for system V, it's like RAX and RDX.
Right. Okay. Let's flip it on. Let's say it's an argument. Like I say, an argument of a struct with two 64 bits ins.
Yeah.
How would
So
you express
I
that?
do whatever the rule is for whatever ABI is. So whatever ABI you have, I'll do the rules for that. And then what I'll do is I'll say, okay, the struct is supposed to be wait, you said two 64-bit integers, so it'd be like a 16-byte struct. I would just say, okay, allocate a stack slot for that. Throw in both of the values from the parameters. Because when you pass in two 64-bit values, you'd get they both come in through two separate parameters. I'd take those two values, store them into a 16-byte struct, and then what you get back looks like a C struct, but it was composed of whatever the correct ABI answer is. You could do the exact same thing for llvm in theory, and like package that up in a library. But yeah, I just do that like built into my like backend.
Right. So I think what I'm kind of trying to get at is that As an example, for example, crane lift is a backend
Mhm.
for like a compiler backend implement in Rust, and similarly, their IR, I think it only has a couple basic primitive types like ints, floats, whatever. I think they
Yeah.
don't even have pointers; they just use ints. When I looked at it, it wasn't really clear. Like, okay, in that setup, how do you express a structure? Because it supported multiple return values, but there wasn't really a way of saying, hey, this argument is more than basically one word in size.
Mhm.
So it wasn't really clear, like, oh, if I have, say, an argument of 264 bits integers as a struct, do I just pass that as a 128 bits integer, or how does that work?
Yeah. In my
Um,
setup, if you want to do like ABI compliant, like calling convention stuff, you would basically just, as long as you describe it as like debug info, which is like as long as you describe it as debug info, that's like limited to whatever the subset is of like C, because there's going to be, of course, extensions to the debug info that are like non-C like. But if you describe debug info that's like C, then I can take that information, not use it as debug info, but use it as a alarm. What's it called? But not use it as like debug info, but use it as a description of a C structure. And then from there I can do the API stuff and like destructure it into my like scalars.
right. So it's kind of like the llvm metadata concept that
Yeah.
they use.
And that way, yeah, that way I can represent like C structs and C struct passing without necessarily like having that as a concept in the backend. Because I don't find the like having the structs in the backend like that like as convenient as they do, because they do it a lot. And what I find more convenient is more of the like the tuple thing where you've got like groupings of information, but they're not like you don't store tuples. You just like there's like a bookkeeping concept effectively.
Right.
Yeah.
Okay,
You
well,
can have like projections to access to pieces of a tuple.
right. No, I think in the IR sense, like if whether you call it a struct or a tuple, I guess it's a matter of semantics. But
Yeah,
I
I just
think
use that term because that's like that's the term I've heard it used, or I've heard people say it by. Like so, in like sieve nodes and stuff, we might have like tuple nodes, and those aren't things that you store in a memory. They're just like a bookkeeping concept for this thing returns multiple things.
right. No, I think it makes sense because the moment you call something struct, people are like, oh, C structures, and like, no.
Yeah,
It's not necessarily the same.
yeah,
So for example, why in my language I don't call these things structs either. Actually, they used to be classes, but they weren't really classes. So I also changed the keyword to type. So now they're just like they're types.
Mhm.
Because the moment you call class, people immediately assume inheritance, and the moment you call it struct, they immediately assume C structures.
yeah.
But no, that sounds sensible. I Yeah, I did actually look at tildes as part of it because
Mhm.
some people also recommend like, oh, you should look at QBE, another compiler backend,
Yeah,
because it handles ABIs and structs. And I looked and I was like, yes, it handles it, but also I cannot find any information on how to produce debug info, which is a little bit crucial for like at least stack traces.
yeah.
QBE does have it; it's just not documented. Fantastic.
Oh, they have
But
debug info. Nice.
Yeah, in the sense that in their latest release, they added like two instructions for like producing debug files and line numbers, so you can at least get stack traces.
Yeah.
I don't know if they will also include the symbol names. Um, but their release notes is like two bullet points or something, and this is not documented at all.
Gotcha.
But I looked at tildes as well, but I think my takeaway at the time is that it was, yeah, still too early.
Yeah, no, I wouldn't recommend like if you're not it is still an early project, so I would expect bugs and all those fun things and a lot of like interaction with me if you need to actually build things with it.
Yeah, I think like for me personally, right now, the issue is, I mean, it's a technical and like adding a separate backend is a bit tricky. It's more that the thing I noticed similar like Crane Lift, for example, it it supposedly has debug info. Like Crane Lift itself doesn't do that, but the WebAssembly runtime that uses Crane Lift does emit some debug info, but they use a separate library for it.
Hmm.
And the problem there at the time was like it's not clear how you combine the two. And currently my language is at the stage where I need at very least stack traces, like as in my unit test suite depends on those being present, because otherwise it
Yeah.
can't figure out, where the test originates from when it produces an error. And so I can't say like, oh, we have this new backend, but debug info is kind of shit, but that's okay, because no, I couldn't run my own unit tests.
Yeah.
And that kind of limits it to basically just llvm at this point, unfortunately. But yeah,
Yeah, I've only got debug info for Windows because it's the easier platform to support. I'll
right.
sit down one day and I'll deal with Dwarf because it's on the plate, but it's like actually so much.
Yeah, the spec is like, what, 500 pages or something?
Yeah, it's massive.
And no, that's because I looked at it. It's like, maybe I'll write my own dwarf. It's like, no, no, let's not.
Yeah, yeah. So yeah, it's the reason why people don't do it.
Yeah,
Or
no,
the big one is actually people will target like earlier versions of Dwarf, so like Dwarf 2.
no, it's like going in, you have this question of why do these backends not support dwarf, or why do they only support x86? And now I'm like, oh, I get it, because it's a pain in the bum.
Yeah, I'll have to get around to it, but my current priority is I started this DSL, so yeah, I'm like populating that thing right now. Right now it just does pattern matching for nodes, and basically I started working with a friend to do the ARM backend, and so he's doing ARM stuff while I'm dealing with x86 stuff. And I was like, oh, I just realized something that could make both of our lives easier, which is that
Which
if I
friend is
had
that?
like
Is
some
it Shaw?
DSL. What is it?
Is that the guy who is on this call sometimes?
No, he hasn't been on this call yet. It's not Shaw, it's Scott. He's in the CCC Discord though.
Yeah, he talks. I mean, he posts occasionally on the Discord.
Yeah. But yeah, Scott's been doing the what's it called? The ARM backend stuff. And so recently he's been dealing with like mostly disassembly. So like my backend targets require like a few different things. So like one of them is that they require a bunch of info of like scheduling. They require a bunch of info about how do you emit nodes, how do you convert nodes into machine nodes, the constraints that nodes have. But then I also have the way that I do disassembly for my for like if I want to do like disassembly output, I just like have a disassembler and I just run it, and then I annotate it with comments that I like describe while building the IR, and then like that's basically it. And so because of that, it's like a full blown disassembler in there, which is useful because I also want to expose it as a normal disassembler because my backend isn't just supposed to be a backend; it's supposed to be like a whole tool chain, like linker, linkers, assemblers, disassemblers, all that stuff. And so because of that, it's really nice to be able to like have just the disassembler, and he mangled through a bunch of like JSON files from the like ARM stuff to deal with basically finding all of the bits to do with all ARM opcodes. And now the plan is basically just to write a DFA over that can skim through like four bits at a time to figure out what opcode or what instruction you're looking at. And then from there, we should have a really nice ARM assembler or disassembler.
One of the long, hard lessons for me was I always write these custom assemblers because I want to be able to read something that reads the same on all these different architectures. So it's a risky, whatever, fine. There's always a disassembler that goes with it. And if you make them a bijection, which is somewhat of a pain in the butt, but if you make them a bijection and you enforce it with testing and all that, it becomes super useful down the line that you can take a wad of assembly that's spit out, edit it in an editor, and then suck it back in and use it again. So there's some effort making it a bijection, but it pays off.
Yeah. Yeah, that actually that's gonna come up soon because the case I want to use that for is that I have like mixed feelings on like whether or not I want to have an inline assembler or like I want to support the ability. And so like logically what it would look like is just like a node that's got a bunch of like goop tied to it, like a bunch of user defined constraints and a bunch of user defined like goop that's in the middle.
Right.
But like for instance, oh, if I wanted to add like hey, this blob of inline assembly wants to like ask for a scratch register. My constraints can like I can do that constraints wise. So as long as I have like a fancy enough assembler, like I could just like by having the bijection, what I could do is I could say like, oh, take this chunk of code, rip it out, and then just replace it with this inline assembly block that just describes the same instruction.
Yeah.
Yeah.
This gets very, very closer to the notion of that's actually how you write the encodings and everything else that comes out of.
Yeah.
Yeah.
That's the thing. Yeah, an inline assembly node is not too dissimilar from any other machine node. It just happens to like hold more instructions.
Yeah. Well, and quite a few machine nodes, certainly in hotspot, have more than one instruction baked into them.
Yeah.
Stupid things for CAS ops or whatever else. They're never a single actual instruction. Read and write
I think
barriers, they don't get if they don't get exploded, then they have multiple ops as well.
yeah.
So
I
I
think the
figured out
most
my
that any one of
symbol
my
is,
machine nodes actually generates is maybe like 3 instructions.
oh God, in hotspot for sine and cosine that used the F87 fancy 80-bit ops, but needed to have perfect IEEE 74 behavior, so all edge conditions handled. Those explode out to dozens and dozens.
Yeah, for me, I would just call a function.
Yes, we started that way. We went to soft float. This is the first early hotspots. All floating point went to soft float. Then went to F87. This is pre SSE, right?
Mhm.
That was a bitch to get through the register allocator. And then sine and cosine and range checks had a bunch of cases that were fairly easy to detect and compile in an optimized way. And it also had a loop that was also fairly low trip count, and you wanted the compiler to like unroll once and the off path like never gets taken.
Gotcha.
So we moved it out of the soft float into FPU and added a little bit of structure around it so that the compiler could do something with it.
Makes
Fine.
sense.
And then SSE came along 2 years later and was like all for naught. Like, what the fuck are we doing here?
Yeah.
Fine.
Yeah, my longest emitting sequence right now is just the like RDTSC read, because it does RDTSC, then it does a shift, and it like ORs the two values because it puts them in two separate registers. But that's like the only like that's
That's it.
apparently as long as it gets right now. Everything else is basically at best like 2, where it's like a move. Because like if I've got like an x86 add instruction, what I do is like I say like if it didn't get coalesced, then I'll insert the move there. And I just do that during the emitting stage.
Yeah.
Yeah.
You might get more. I don't know. The C code, maybe not.
Yeah.
Um,
I imagine I'll run into a few extras that'll be like bigger, but I don't have any big built-in like runtimey bits like barriers. And so I imagine that that's going to save me on some of that.
and then anything you do with locks is
Oh,
code
that too.
that you do something there. Or
Yeah.
thread local storage access or whatever. There's a couple things.
Oh, that's true. Yeah, thread locals are probably the other long one because those are like 3. Oh no, but I split those actually. So those
You
are
break
actually
them up
separate
already.
instructions.
Yeah, fine.
Yeah, because the nice thing about splitting them is that they can global value numbers separately. So I can actually
yeah.
so I do instruction selection before I schedule actually, because it leads to like some really funny details. So one of them is that it means that like so I ran into this with llvm. There's a selection DAG, which is like basically their like normal instruction selection for like like normal optimized stuff. And then there's this other one that they were working on for like the longest time called global ICEL. And the idea was to like, okay, selection DAG is like limited to basic blocks. We want something that's like, able to work across basic blocks and do a bunch of other things and basically solve some of the problems that selection DAG had. One of the funny details I realized is because I like can do instruction selection without having like actually scheduled a graph,
right.
There is already global instruction selection.
Yes.
And so in my case, it's like, okay, if I have like the TLS and I like unpack it into like, this one like reads the GS register, this one like loads from like the TLS index, and this one does like the actual like TLS load. Those 3 instructions, 2 of those could get hoisted if I wanted to. They could get shared across multiple TLS loads. They could get hoisted outside of a loop or whatever the hell else. Like
right.
There's nothing stopping it from doing that.
Right.
It's actually useful.
Yes. I do the same thing for the same reason. Yes.
Yeah.
Fine. I figured out what happened with simple. It was a cascade of 3 unrelated things, 2 of which were not really bugs, but just misunderstandings. And there was an actual bug that I fixed while we were talking here. I'm going to go back and we'll take a short look at this thing. So the first bug was this was a car. I don't actually have a car defined type. So he assumed it was a forward reference to a yet to be seen struct car array of some kind of thing, whatever it's going to be. So that was one bug. So I put it at U8. The next one is that in the body of struct, body of string is a forward reference. And he doesn't know that he had a CS field because it was at the bottom. So all the references to CS fields inside of here were all complaining about being forward references. So better error messages would help, but I pulled all these functions, which if I were to have them as methods inside the body of string, they would get access to the full set of string fields. I would have to sort out the forward reference problem there. It's all doable. Pulling them out let it work as expected. And I'm up to this thing where all these three functions have been pulled out. I have several things I wanted to show here because people asked. So one of the things on is I do in fact know that the car array CS is not null. So if you look at the error message, it's string is not fully initialized, fields S needs to be set. So one of the things going on here is that by not saying anything special about the CS array, because it's an array, the assumption is it's not null, the CS field itself. So I can't make a string object without filling in the CS array. So if I just do this, I've now declared a string with the CS array filled in. And then I can do other things. And then comes this error message, which is back to being this horrible thing to read. And it's really down to the int hash code field needs to be a bang hash code, it needs to be mutable. I'm mutating the hash code. The hash code is lazily set. The string is declared as a final string, so I can't mutate it internally with a hash code. Same problem as C++ const. And why you castaway const? Conceptually, string is immutable. In practice, it's actually mutable because you mutate the hash code because you lazily compute it. So it has to be banged here. And then I compute the hash code of CL as, part of Cliff. And presumably it got cached, although I didn't check it in my little example here. So that was all I wanted to show. To make these things, methods, they have to have the scope of string plot available to them. I gotta go, Cameron. See ya. And that would make them, live inside, and then I don't have to pass a self argument. And then the self argument becomes a same or a self or this or whatever, it becomes some shortcut. So that's that piece. The other one that hasn't showed up here is using arrays and strings, where if you have an array as the last element of a struct and you don't give it a name, the theory says I would fuse it. And the way that would work is references to the string object as an array would directly get at, let me do this. Let me do that, I'm typing too fast. Would just be allowed to reference the elements of the array. And if I were to move like hash code inside, and I would have the correct scoping rule, so I'll just type it out, but it won't be the correct scoping rule, so it won't actually compile. Then the array would just be would never be null. I would demand it, so I wouldn't need this test that was there because I was trying to debug something I didn't understand what's going on, but you would actually be able to refer to the array element directly. You get elements straight out by just asking for them. You don't need to pass anything. You're a function, you're operating directly on an array, you have direct access to the array length and direct access to array members. Equals has much the same flavor. Let's see here. You wouldn't need the self, except that you want to have a self equals this test. And then array length would be other guy's string directly his length, and walk and refer like this, and so your equals call would look like that. It just shortcuts everything. But the main benefit for me in my head is that outside of the string codings, when I use a string, I can say, what is the length of a string? Well, it's string length. And, what's car at? Well, it's, car at is this. So it looks like an array of characters. But it also has functions on it. So I can say dot equals of some other string. So it's both a struct and an array. And it does the sort of standard struct thing as well. And then the implementation is the obvious thing. You have a trailing variable length array, and you have a leading prefix of fields that are named access like hash code. And the vowels, the final fields, get moved off into the strings prototype. And so they don't take up any space in the string object itself. All right, well, that was it. That was it for that demo.
What would the syntax be once you unify to indicate which field is the anonymous repeated field?
The unnamed array declaration. And
But if you
probably,
switch the order of that, like, does it have to be last?
I don't, because unnamed is sufficient. So we could argue syntax here. You can have only, it would allow you to have an unnamed, and you can only have one. That's your array. That's your.
So that's the difference, is it will explode at you if you have two anonymous arrays in a struct.
Yes.
You only get one.
You only get one. Yeah. And that's because there is for some to say, sort of for free zero overhead implementation. And C guys have been doing it forever and a day, and why not kind of thing. C2 does this kind of shit all the time with variable length.
The thing that makes me wonder is if you should be able to get away with a anonymous field in a struct or an anonymous struct in a struct.
AA does the right type analysis to get away with that, but not
simple.
Not here in simple. I'm not doing Henley. Like the AA thing is like very beefy. It's Henley Milner with a lot of extensions. This one is simply forward flow typings like C2 has done for 30, 40 years, like Fortran compiler, C compiler does. I get more inference than most, but not really, not these days. I'm doing all that same inference that everyone else is now doing, but they weren't doing 20 years ago. Well, you're doing it now. So when you define like the equals call, what's the return value from equals? Well, I don't declare it up here, but I infer it by looking at it's all return booleans. Return value is boolean, done. Same for hash code, returning an int and all that kind of stuff. So it's standard forward flow type inference. You have to have a type. So one of the bugs I was fighting while we were trying to do the live demo was I had this field, named CS, had it down here. And because I didn't have the forward reference handling done for methods inside of a struct where the struct is not yet declared, no one knew what a CS field was. So they'd all blow up on, you basically have an undefined field here. So we'll declare it a forward reference to a function we haven't seen, but it's not. It's an array. It can't be declared as a forward reference like that. I have to do something else. So I don't have forward references sorted out in.
Well, you do plan to have forward references.
Yeah, no, they're
sometimes it's nice to write code with cyclic references.
Yeah, you're right.
So
forward
references are important.
Forward references are sorted out for structs referring to structs and functions referring to functions. But if you put a function inside of a struct, I don't get the string as a forward reference available. So this string is a forward reference because I'm in the middle of defining the struct. So there is no string yet, or there is a string. I don't know what the fields are. So I have a string object. That forward reference works. I don't know what the fields are because there may be fields below the function down here. Right? Exactly how I wrote the thing was, I'll put these fields down here. Okay, when I'm looking at the string equals here and now in a function, and I'm taking a string and I say string what? Well, it used to say string.cs. Okay, what's CS? There's no field CS because it's a forward reference. So that wasn't working because it was a function inside of a struct and the struct declaration hadn't completed. But structs referring to structs, functions referring to functions, those all work right now. So factorial lives on, Factorial is a function which takes an in here and says n is less than or equal to 1, return a 1, otherwise return factorial of n minus 1 times n, right? So this fact is considered a forward reference because I haven't actually defined the left-hand side yet. Works great. The other one, struct linked list, has a linked list that can be null next. It has an int payload. That works great too. So this is a forward reference, right? And multiples where is even function calls is odd calls is even work, and multiple cycles of structs referring to structs cyclically work right now, but not a forward reference of a struct inside of a function. So an equivalent failure for that one would be bring equals up here. And even if I say, you know, string self, comma, and I make all the self things behave as you'd expect, there's no forward reference on string support for asking for fields. So s.cs says, give me the forward reference definition for string. I don't have that implementation. So in the land of forward only flow typing, I need another pass. There is a thing that says I can start looking at string and declare it has to have a CS field.
I was going to say, do you need another pass or do you just need some kind of stack that's like,
Well, you have to stall. So
I
I
pushed
come to
this
string
thing
here. So,
onto a work list, and now every time I define a new symbol, I check if there's anything I can pull off the work list.
so I come to var equals, I see string. I don't know what comes forward. The red stuff down below, I have no idea. The parser hasn't seen it. So what is string? It's a forward reference to what? A function? Is it a function type? Is it a struct type? What kind of thing is it?
Right. I
Parser has
basically
no
want to
idea.
go all the way to the close parenthesis and throw that whole thing on a stack that says I'm waiting on.
Yeah, delay. Yeah, that's the second pass. You're coming back around. You have to parse. So you have to parse out this stuff, and then you don't know what to do with it. Now, the minimum parse I could do here is just do balanced parens and do exactly what you said. Throw this on a stack, not on a stack, on a to do later. And then I come forward and carry on, get more things I do know what to do. And then I come back around to this and say, oh, I found more shit, I'm good. But I would actually not even know that I couldn't make progress until I first said, this is a function. So this is a variable assignment. Variable assigning equals. It is a function. Oh, it has something of a type. That's a type, but I don't know what the type is. Now I don't know what to do. And then I have this issue of, you know, what's the way to resolve that? And then you get a pass and a half, if you will. You get another pass of some kind. You have to delay something. Henley Milner says I can do it in one pass because I can come through here and say s.cs. So s is a thing that has a field, cs. So it's a struct with a cs field. Furthermore, the CS field has an array length. Therefore, it's a struct of the CS, which is an array. And then I can come through and do, you know, whatever. This is an array, and then I'm done. Now I know that string has a CS, and it has the CS as an array, and doesn't know anything about hash code. It might have a hash code, might have other fields. This Henley Milner will do that. So the Henley Milner can do this in one shot. And then you come to struct and struct string, and you start saying, oh, you actually have some stuff. You have this CS field, and in fact, it's an array, and I now know what the type is, and so on and so forth. But the actual doing it in simple, I'll have to sort myself out. At the moment, I've gone ahead and declared this is okay to demand you declare the string first, then the equals call, right? And that's just a limitation of where simple is right now. And now what do I do for references here? You know, there's no easy, quick answer. When I move it on the inside, I'll either do a fake thing for the type flow where I add fields later. Like I know that a self-reference to struct string has a has a struct. And if it's a fused guy, like it's here, and I look up CS and I don't find it in the current scope, I can assume it appears as a forward ref in the string scope, and that actually should work. And then it shows up and I'm good. If I just have the array length, then it's the same story. The array length demands that I have an array. A struct, it picks up an array declaration in a minute. So I don't know. I'm still work in progress here, but I think this kind of excites me as being like, okay, we're gonna have methods, and it's not a hard thing to go do. I guess equals, it looks a little nicer. Drug on the inside, examples a little nicer. because I kind of come through and say, well, I know I have a self, but I have a string. And as soon as as soon as I have a string, I know this string is equal to the string I'm in, but I don't know anything about it. So it's a forward reference to a string. And then this would declare I have a CS field, and this would declare right here also I have a CS field. So I think it works out the same. I think I can make a method here, ignoring the fused struct array. I think I can, without making a second pass, I can declare forward struct refs, which I already have, can pick up fields on them. And I'll just add the fields and declare it a forward ref field, and I'll have to pick the type as I go. Be just like I'm doing type referencing on the CS field. And as soon as I hit a declaration for it, I'll assign it. So I think this is straightforward to do in the current simple layout. And that will give me methods.
Do you plan to have some kind of hidden mutable fields not making the actual thing mutable?
Not right now. And so that gets into what the hell
Okay,
you
so it's
do.
just strings are mutable.
Yeah, this is a hard problem to go question yourself on. There are several routes here. I don't have immutable arrays. I do have immutable arrays. So the obvious string is do a defensive copy and declare it an immutable CS array. Then if you do that, you just pre-compute hash code, and now you're immutable. The constructor for string can totally run arbitrary functions. So I could make this hash code be the result of computing the hash, right? I mean, and then then I can declare the string immutable. And you're done, And then if it were immutable, this would fail on you because he would say, no, you're an immutable guy. You can't do that.
Yeah, I had assumed that that's what Java was doing, that it calculated the hash when you created the string, but I guess not.
I think there's more special things they do specifically with strings. Like I know strings get extra rules on finalizers and how finalizers work that don't apply to any other class. So that they close some security holes in strings where you first made a string and then in the string constructor you escaped it and then you filled it in and then the escaped string got escaped early and you could racely fill in with things and see pre and post fill in on the string and shit. It was like they had to work hard to make strings not break the security in the world. I don't remember now what they end up with hash code being immutable on strings or
It's just
not.
lazy on string.
It's just what?
The hash code on string is lazy. So defaults to
is.
0, and first time you call hash code,
Yeah.
it computes it and stores it, and hopefully doesn't hash to 0.
Right. Well, I have my hack for hash to 0 by simply.
Oh, actually, yeah, they have a hash to 0 hack in there.
Yeah, they do. I saw that one, which tells me that it was probably lazy. Okay, so that means that strings are not final. They just don't have an exposed API that has any mutable state on it.
Is the hash to heroes act just if the hash is 0, return 1 instead?
No, in
I
case
wish
of
it was.
strings,
They burn a boolean.
they burn a boolean. Yeah, they burn an extra bit. I always thought.
They burn it. They burn an extra byte, but
Yeah, right.
maybe,
Yeah, fine.
maybe
Right,
a bit.
but there's not that many strings that hash to 0. Like,
That's
if
correct.
you
I
just
totally
make it so
would've-
there's twice as many strings that hash to one number as all the others.
Right.
My
Fine.
guess is they were locked into the spec because hash code for string is actually part of the spec, not implementation specific. And
Right,
if they
right.
screwed it up, they don't ever get to change it.
Right. So if you had a 0 hash on this string, you can't change the Java rev and get a non-zero next go round. Yeah, this pattern I wrote right here for the string hash, that is the spec Java hash for string. It's not a terrible hash. It's not a happy one if you have a multi-gigabyte string array because you visit every character. Fine.
That was one of the fun little quirks that we ended up with at Twitter because we started as a Ruby on Rails app and then evolved into Java microservices.
Yes.
One of the most commonly called functions in all of Twitter's data center when you added up things across all the machines was a Java implementation of the Ruby string hash function to figure out what the Ruby hash code for a string would have been.
And could you change that hash?
No,
I
you couldn't
mean-
cache it.
Cache it too. Oh, you couldn't cache it because it's on a
But you
string.
couldn't cache it in the string, right?
Can't
So
cache it in the
hence
string.
hence it came up a lot.
Oh God. Oh, that's terrible.
It's just one of those moments. It's like if we were building this now, we wouldn't do this, but
Yes.
it's just not worth the engineering time to fix in a lot of
I mean, couldn't
places.
you? That's what I'm asking. Couldn't you get rid of Ruby string and just use the Java string hash? And you're saying
Many of the
no.
places, yes, but there were services where the
Fine.
APIs they had agreed to speak to each other was about referring to things by their Ruby string hash.
Ruby string hash was the communication protocol.
And you would end up with services that on one
Wow.
side were Java and on the other side were Java, but were speaking to each other over Ruby serialized object protocol. They were just both having implemented Ruby serialized object protocol.
Versionitis. I hardly knew
And every once in a while, someone would bring it up and be like, should we replace this with a proto
Uh-huh.
buff?
Uh-huh.
And the answer was like, we would use that if we were doing it now, but like it's not broken, so
Right. Yeah. Yeah. Well, that's Twitter.
why do the complicated coordinated update of update
Uh,
service A to speak protocol A and protocol B, and update service B to speak protocol A and protocol B, and then update the two services to both not speak the old protocol anymore?
right.
You
Right.
have to do
When
this
you could
like
just buy more hardware
ratchety
instead.
update.
Right. Right. Or just buy more hardware.
And it was just like
It's
not worth
Musk's
it.
problem now. He gets to pay those bills or not.
Well, their solution was just turn off both microservices and see if anything breaks.
Yeah, right. Yeah, yeah, yeah. It sounds reasonable. Fine. I have now got Bluesky and Mastodon accounts also with my my once a week Twitter usage. All right. So
Do you know
going,
Bluesky is based on my thesis work?
I'm sorry, what?
Did you know that Bluesky is based on my PhD thesis work?
No. Congratulations. They're going to give me any credit?
I got 2 sites from patents, 2 sites from papers, and 1 social network launched on it.
There you go. You'd probably get a free Bluesky account too.
Hmm?
So you probably get a free Bluesky account too.
Yeah, I'm employee 4, but thanks to weird testing quirks, I'm like account 37 or something.
Oh, you're at Bluesky now.
No, I was at Bluesky.
Ah,
I was the 4th employee at Bluesky. I am no longer there.
okay, fine. Too bad. That's fine either way. Yes, I hope there's a reasonable replacement. Keeps trudging along here for Mr. Saluda Baconic, whatever, Mr. Musk here. What the fuck, dude? All right.
Oh no,
Yeah,
no, he
US
just has
elections have a
Asperger's.
surprising effect on countries that are not the US.
Oh, I imagine so. Sorry, Mark, what are you saying?
Oh, I was saying no. Elon just has Asperger's. You didn't hear?
He went to
He
what?
wasn't. He went. Elon just has Asperger's. He's not a Nazi.
Uh-huh. Yes. Yeah, that's interesting information there.
Yes.
All right. I'm out of demo. Anyone else want to bring anything up? Or we'll call it and go to lunch.
So I did have that one AA syntax question from the chat where you were like, hey, the first use in the function,
Oh, yeah.
if it's a right, then you shadow the thing that's on the outside, even if the thing on the outside exists.
What did I say? How did I say it? They're right. Yes. So when do you get to shadow and when do you not in general? In the land of C, Java, whatever, you shadow as soon as you said int x equals. You shadowed. Right? That if you're inside the inner piece and there's an outer piece
Right.
and there's an x and you int x, you just
But
shadow.
if I just say x equals and I don't initialize it,
Yeah.
then it's going to go looking for it on the outside.
Yeah. No, if I say if I just say x, if you want to, yes. If you say x equals 3 or just use x, he looks on the outside because you didn't initialize it. Okay, so in the land of node
But in the land of
declaration,
AA, that's not true. If I
right,
say
yeah.
x equals 3,
So I took Python, inspiration from Python, and said if you assign to it first, your intent is to make a shadowed new variable. And if you read from it first, your intent is to read it doesn't exist, so your intent is to go read the outer scope. And I gave myself a cutout somewhere in there that said go to outer scope and write it. Oh yeah, the cutout's easy. You just read it once, a junk empty read, and then you can write it.
Yeah, so if you look at the doc, my assumption is if I want to read the X from outside.
Hang on, let me share doc. Well, I mean, keep talking. It won't take long if I can find the correct window. How about this window? Right. So there's your first read, and now you have agreed that you're overriding the outer guy.
But if I don't have that,
Then the
then I'm
theory is
shadowing.
you're shadowing. Yeah. Now simple requires you to
Now
have
this read doesn't do anything, but
Yeah.
also does
it
like
syntactically does something. That is a key to the parser that says the variable X is declared in an outer scope. So that has no semantic meaning and no type meaning, but it has, well, semantic. The parser reads it. It generates no code, but the parser reads it and does the lookup and agrees that in this scope, the X he's referring to is the outer scope. And when you come to the
I
next
would be
version of X,
afraid to use that language feature without the comment saying
yeah,
this
outer
thing
scope.
that looks like it does nothing is to make X the non-local X.
Right, and you've already agreed that you've made a function and you're referring to something out of scope in the function that you're side effecting. You're going to pass that function along to some other far distant place, and he's going to reach backwards and whack X. This is an odd, unusual story already. So I claim you're in the land of this is not expected. And
You're in the land of you
so,
better have a comment because you're being weird anyway.
yeah, danger, danger, Will Robinson. I'm already being weird. Yes. Like you didn't say it, but suppose you said return this function. Oh, I just made a closure that's referring to a value that I'm going to mutate after the fact. That's you can't do that in most languages because it's a true closure, right? And then the other one is I have a lambda, and the lambda is touching outside of itself into its current stack frame because I'm updating X with the found value and I'm doing a generic map over an array, and I'm passing it a find, and he finds all instances and he updates X or something, whatever. I don't care. But
I
you're
mean,
still
using it as
updating.
a true closure in order to like, I hand you the encryptor, but I don't tell you the key.
Yeah.
That's actually one of the use cases I think is most common for this kind
I'm
of
not claiming that
behavior.
no one does closures. I'm saying, or that closures are useful. I'm saying you're using a closure in a real way. It's not even that you're mutating via the closure. This is not your security key case where you're just reading the hidden key. You're actually writing to it. And that I claim is even more unusual.
Yes, this is more akin to the incrementer closure.
Yeah, that's my
than
incrementer closure example. Right. And in Python, you call it generator. So in all those cases, I claim you wrote weird code. You should comment yourself.
Okay. And the fact is you can do it. So
Yeah. So just,
like
I mean,
this syntax is not terrible and is definitely worse than
well, I would
that
have,
doing the mutating behavior.
if I wanted to specify the difference between mutating and not mutating, shadowing or not, I need some other syntax here. And in the other languages, you use a type declaration, int, var, something. And you need type declarations. Then everyone gets type declarations.
Yeah, this is a pretty minimal syntax. I'll give you that.
Okay. So Python, I think, has a global keyword that they use to
They
say,
have two. They have global and they have non-local.
okay. So somewhere in here, you'd come along and you'd say global or
Global
maybe
X, yeah.
non-local or whatever, how you spell the keyword. And you'd add a keyword here that says, in particular, I'm referring to X I'm not defining it here. I'm using the one that comes from outside. So there's another syntax. Pick your syntax. I don't know. There is a reason to use a keyword in that it's weird what you're doing, and this forces you to admit your weirdness directly in the code. Now, having said that, I can syntactically detect the situation without the keyword. But it might be worth a keyword here to say,
Yeah, my instinct there is keep the language clean and just use this read that does nothing.
Yeah.
And then add a lint rule that says you should never have the read that does nothing without this comment.
Without a comment. Yes. Yes. Comment. Hey, I'm doing something weird here. Yep. Okay. Fair enough.
But that does solve my problem of I don't want to look at a function and not know whether I'm mutating something global, because not realizing you're
Yep.
mutating global mutable state
Yeah. It's
is an
dangerous.
easy way to write a bug.
Yeah. Yeah. Simple doesn't have any of that, so no problem. And my hack for methods just says it's not really global. You just got handed a silent, quiet this pointer, and then you got a this
Yeah.
pointer, and you're mutating a struct. Oh, fine. It's not global. It's the struct you got handed. Fine.
There was one project I worked on that was a very old code base, and they had a bunch of custom print functions
Yes.
that turned out all shared the exact same 4K of memory.
Ah, sure.
And it meant you weren't doing allocations for these prints that were happening all over the place.
Right. Right.
But if you ever had the point where you had two different threads that both tried to call print and you didn't do some kind of lock,
Right.
then you'd get the garbled mixture of two print statements.
Right. They collide. Yeah, I've done kernel. I wrote kernel before, kernel debugging. There's a no stack, no memory allocated print code running around that needs a little bit of space. And there's only one of those, and it shares. And yeah. So if you're in a print and you're trying to debug why the fuck your print did weird things because your toString on your print was bizarre, and you recursively called print again, you got trashed.
Yeah, non-deterministic print. When you run the same thing 3 times and it prints different garbage each time, and you're like,
Yeah, it took me the whole lesson about print functions having side effects, hiding bugs. That was a C2 killer bug where the immediate dominator, the lazy version of immediate dominators with mutations that was not correct, it was a conservatively correct one, pre-loopbox, had a union find thing going on with it. As I deleted control flow AR, I would roll up the lookups with a union find effect so that all immediate dominators would do a one-step thing, even if you had regions and whatever. Weird thing. You could do whatever you want. The peepholes could do shit. I still get constant time immediate dominator approximations, but we do rollups. And then I had some bug in the rollups. And then I was trying to debug. It took me maybe more than a week to realize that the main part of the bug was if I stopped the debugger and printed anything, that did the rollup in the print, and then my bug went away. And I stopped where I knew it was crashing outside the debugger, and it would stop. And usually it's deterministic, highly reliable, and I would single step through and look at things and figure out what the bug was. In this case, I
that's
stopped.
not something the language can fix, because if you implemented a toString, your toString does whatever your toString does.
Yes, and the toString has side effects.
So if toString mutates, then toString mutates.
Mutates, right. And of course, the main trick with it mutating was it just called the normal accessor. Hey, go get me this thing. Go get me the immediate dominator field. That's the normal accessor. The normal accessor mutates because that's what union find does. So it was all very upfront and honest and open and obvious. You wanted the dominator field, you called get me the dominator field. And it just fetched a thing, or maybe it ran through a couple pointers and fetched and rolled up behind your back and fetched, but it did a very straightforward thing. Here is the immediate dominator field. And of course, there was a bug somewhere in there, and the answer was it hit it when you called print. And the bug was always somebody got the dominator field without calling the dominator accessor. So they got a stale, not rolled up version. And then as soon as you print, it rolled up. And now when I stepped through the code where it was stale, and it was nested deep within other things, so I'm stepping in big chunks trying to find it.
It was always
already
fresh,
rolled up, so it's correct.
because you were printing it all the time.
Because I was printing it, yeah. Is it dead here? Step. Is it dead here? Step. Is it dead here? Step. Is it dead here? It was never dead. Okay, go back, stop here, run it, crash. Okay, stop here, print, step, no bug. Stop here, continue, crash.
Yeah.
Stuck.
And picturing that algorithm that's like, smell the milk. If the milk smells bad, replace it with good milk.
Uh-huh. Yeah.
Now you keep getting sick, but when you cook it where you stop to smell the milk to check if it was bad, it's like, nope, the milk was good. Because you don't realize that what smell the milk did was not check if the milk was bad. It was check if the milk was bad and replace it.
And replace it, yes. Yep, that is exactly what's going on. So variants of that show up all over, and I have these parallel streams of accessors and printers that don't do the accessor thing. Fine. But yeah, now I don't have those bugs no more. But it did take it's one of these, hard knock learning lessons, right? Doctor, it hurts when I do this. Don't do this. Oh, okay.
Well, there's almost
Fine.
some of the opposite of that, where I knew a bunch of people who grew up writing C and C++, and they just tend to write code in ways that allowed them to not use after free all the time.
Yeah, yeah.
And they've just gotten into habits where they're not even
Yeah.
thinking, I'm
Right.
doing this because it enables me to manage memory well. They're thinking, I do this because this is the pattern that I know easily and can do without thinking about it.
This is Levo's problem. He knows how to write this code that he can do memory management with. He doesn't know how to describe how he writes his code, but he does memory management with.
And then you realize that systems have bugs in it because the person who developed the system just sort of assumed everyone was going to follow these patterns.
Oh, yes. Yes.
Because they think in those patterns.
Yes.
And then somebody else shows up and they don't follow that pattern, and
Right.
suddenly you've got use after free bugs.
Right. And yes.
Or you're in some garbage collected world where you were getting really good performance because you wrote in a really memory manageable way. And then suddenly someone comes and makes a change that is not unsound because it's Java and there's a garbage collector guaranteeing that it is sound,
Right.
but it's suddenly way less friendly to.
Yeah. I wish Derek was here because he's been going through this with simple versus his implementation internally, where he didn't understand a bunch of the things I was doing. And he's picking up, like, even this last week, he picked up like, oh, now I understand what this is about. And then I understand why it's efficient, and I understand why you're doing it, and I understand why it's so short and simple, but he hadn't been doing it and was leading to whatever. His version of things was 10x slower than my version of things, but more like
It makes
100x
sense.
slower.
The one place where I run into this is I was modifying some Python thing. And the person who had originally written it had basically no cycles in their object graph.
Yes.
Because they just sort of think in this ownership tree.
Yes.
And
There's a
Python
penalty
does a combination of reference counting and then a mark and sweep garbage collector if it's getting pressure.
Right. Yep.
And I made what I thought was a tiny change.
Yeah.
But it was the difference between not having any cycles in the graph and having a cycle in the graph.
Right.
And suddenly I broke the reference counting that was doing all of the deallocation. And you make this tiny change and the performance just fell off a cliff.
Yes. He'll also do
I was totally blindsided by that. I could not figure out why
this was killing you.
Yeah.
Yeah. What do you call it?
But fortunately, we had an old guy there who was like, well, let me tell you the story of reference counted garbage collection.
Yes. Yeah, I mean, I've told this story about finalizers in Java where it was Tomcat. Early Apache Tomcat server was using a thread per, and early heaps were small, and you ran some requests, and the heap ran out, and the GC cycle ran, and the heap was small, so GC was pretty quick. And the GC ran the finalizers, and the finalizers closed the file handles. And over the time, and this model worked really well, and things are great, and then people got bigger machines, and they could handle more load, and put bigger memories, and you would run longer between full GC cycles. And eventually you ran so long that you had more than 65,000 requests. You ran out of 65,000 file handles. The OS returned, you got no file handles because you didn't run a GC cycle. And then there was all kinds of screaming and yelling and shrink the heap and force cycles and system.gc in order to get finalizers to run and all kinds of shit going on. And eventually, one of the, and I guess now mid-tier range elements of hotspot sorted out that if you get an OS out of files error when somebody asks for a file handle, you don't throw an error. You stop and you force a full GC cycle. After that full GC cycle, you try again to get a file handle. And if that fails, now you're throwing out a file handles error. And that was just this background hook to let everyone who does thread per support with large heaps and finalizers that had, OS handles in them. It's like, oh, come on, guys. This is a bad plan for handling these kind of things, like reference counting And try finally was a long ways off and giant syntax. But in C++, you just put an object on the stack that had a destructor. And when you scope exited, just like try finally, but with no syntax, it cleaned up. That was a great way to do cleanup. I don't know, it took Java like fucking 20 years to figure out C++ destructors are actually a great way to do cleanup of stack lifetime things. Fine.
Yes. The fact that you have a garbage collector does not mean you shouldn't have destructors.
Yeah, exactly. Exactly. Especially for doing things that are outside the realm of the garbage collector, like OS resources. Ugh. All right, done and done. I think it's time for lunch for sure. Any last requests before I pull the plug here?
Do you have any ideas for how to expose to user space how they should? So, like with the file handles, there was a clear answer of where out of file handles, try the GC so that we can run all the finalizers and see if that cleans up.
Right.
But imagine you have some resource that is a very application specific resource.
Right. So the
And the
first step is
finalizers were going to free up that very application specific resource.
right.
How do you give the user the hooks they need to be able to say, hey, what just
Right.
happened was we're out of application specific resource.
Yeah.
Can you please
This-
run
this-
as many finalizers as you
Right, this
can
is a-
to see if we can
This
continue?
is an easy problem. It's the same problem I just talked about a second ago. School of Hard Knocks, you whack them on the head with a 2x4 and they quit using finalizers. Don't manage your OS level resources with finalizers. Sort it out yourself internally. And that means you have reference counting internally, you have some sort of app specific lifetime management game. Don't use finalizers for your
Okay,
apps.
so your answer is if you have an application specific limited resource, manage it.
Manage it. Yes. Yes. Quit asking the GC to manage your very specific resource requirements. It doesn't know how to do LRU in caches, so all of your weak reference caches get flushed randomly by GC, not in any sort of intelligent way. That's like a really bad plan to have the GC manage your LRU weak ref cache. Bad plan to manage file handles, bad plan to manage graphics card buffers for doing, games in Java, whatever that came and went. But yeah, fine. All those things.
Database
Yeah.
connections. There's a whole pile of these.
Yeah. Finalizers are just generally a bad plan because the GC has no fucking clue when and where and how that resource should be reclaimed. And you have no clue when the GC is going to do it. For the same, the two can't talk.
Yes, you have to simultaneously assume that it does it every cycle between every single instruction and that it will never happen.
And also never happen. Yeah, exactly. Exactly. It's just a bad plan. All right. I haven't had the whale on finalizers talk in almost 10 years. It's good to have it, but it can be done. All right. Bye-bye.
I doubt that's the final time you're whale on finalizers.
Yes, I have my favorite whipping boys. They'll come out again. Yeah, probably. All right. Good night or afternoon or lunch.
Good night.